Welcome to part 4 of Competency 18. In this video, we will discuss regression models and errors. Before we begin, let's discuss some terms that relate to linear regression analysis. The first one is least squares. Okay, this is a very brief definition. You might want to go and watch some videos relating to that. There's lots of good people online. Okay, this provides an overall rationale for the placement of the line of best fit. That's what we're going to be working with. Best fit among the data points. We're going to use our data points again. I had another video earlier that dealt with this. This is just more information and adding in errors, a little more discussion. Okay, so we're going to work with the best fit. Least squares are very important and where they come from. Okay, residual. This is the difference between the actual value and the value predicted by the model. So this is what they mean right here. So basically y is the answer to your equation, right? So this first y, that's the y that's given. That's like the actual piece of data. Okay, that's the actual y value when you're doing the experiment. Then this y hat here, that is the y that one would get from the equation. Now, if you've done best fit, you remember it, well, you'll know that your line just kind of goes through the middle of your data. Rarely is it perfectly on your data. Okay, this is for any given point. Okay, a least squares regression model minimizes the number of squared residuals. So that's where the term least squares come from. Okay, there's a process of squaring these residuals and moving the line around till you get the best one. Luckily, we have the TI-84. We don't have to mess with that. Okay, we just have to understand where it comes from. Okay, then you have your your correction coefficient, excuse me. And this, in some cases, that's why I have these letters here. That means error. In some cases, this R is represented by an E, a type of E for error. It depends on the topic and the purpose, okay? So generally in education at the level of algebra, you're going to use R and the correction coefficient, okay? This describes mathematically the strength of the relationship between variables, and that's from -1 to 1. We briefly did a little of it, couple questions, small explanation, but that's just a little measure for you. If it's close to 1, close to -1, you know you have a nice, strong correlation, okay? All right, now let's keep going. All right. This coefficient of determinant, that's your R squared, okay? And that's what we were talking about. That's how you work and get your best fit. Now, it says, yeah, that's the goodness of fit measure for linear regression models. Okay, yeah. And it's a little process. That's in your process you use. So you should know this. Okay. If you don't, please go watch a video and then come back and practice with my videos. Okay. Okay. It measures the strength of the relationship between your model and the dependent variable on uh, well, it says a convenient. I don't know about that. Sorry, it took me a second to see what word they mean there. Okay, I don't know how convenient. What it means is you've got 0 to 100, closer to 100%, the better you are. And our calculator gives us that. I'll come back to it. Now, This is what we need to remember as we're working today. Okay, this is the prediction error. Okay, so we're going to go through the process, do what we did before, make our line of best fit. Then we're going to have a conjecture. Okay, what if we get one more piece of data? How would it fit? Okay, what percentage would that be? You'll see. Okay, and there's a reminder. And this is the first image we should get right here. First one we should get. So let's do number 1. Okay. Write a linear equation that best fits the data in the table below. Okay, we've done this before. So we go to stat, and it's already highlighted with a 1. Go to enter. Okay, I have it populated from something else I was doing before, so I am not going to erase all my work. I'm just going to add a number 7 down at the bottom. So push 7, then push enter so it takes. Okay, but that I'm going to clear. How do you clear? Highlight the L2 for everyone's sake. Please don't push delete. Push clear, then enter. Okay, this is one of those cases where delete is super bad. Okay, so now we put in our data since we've cleared it out. So 1.5, enter. 3.8, enter. 6.7, enter. And 9, enter. 11.2, 13.6, enter. Am I getting this in right? Let's see. Yep. Oh, yeah. Okay. And they end even, so that's one clue. And yes, looks okay. All right, now the next thing we need to do is back out. This is one of the cases where you have to back out. Okay, now we push stat. And we're going to go over to calc, which means, hey, I want to take my L1, L2 and do some calculations. Okay. All right. For this one, we want an equation. So remember, we go down to number 4, which is a linear regression. And we've already populated it with L1, L2. If you don't remember how to do that, you need to push second 1. See that L1 above my red highlighted 1? Push enter. Second L2. See what I did? Okay. Now, you can't just go down. You have to stop on this regression equation. Okay. We need that. Push vars. Oh, I went too far. Go to vars. It's already highlighted on function. We enter, and it's going to be in the Y1. Enter, enter again. I know there's a lot of entering. Okay, this sets me up. So if I want my R correlation, if they ask me for that, it's really close to 1, which is awesome. Your R2 we just talked about, that's almost at 100%. It's at 99.9%. That means this is a great model. It's a super fit. Now, if we want to build our equation, it's right there. Remember, A is your M. Y equals mx plus or minus b. Remember that from middle school. Okay, so our a is 2.4. Remember, your a or your m is before your x. So I've got a lot of good numbers. Okay, b, I don't like because my x is over here. Okay, and this one has an x with the wrong number. And this one has an x with an incorrect number. Okay, now I skipped my value of my b value. So my b value 0, 1 with rounding. Yes, that's the culprit. Okay. Now my next question says, use the information from number 1 if another set of data were x equals 8 and y equals 18.1. Okay. That's like saying, hey, oops. That's like saying, okay, we're going to continue out our data. We've got some more data. Let's put it in on the end right here. So there's an 8 and an 18.1. Okay. We have, you don't see it, and you should know if you've done this before. Okay, if I push my y equals, there's all my information. Unrounded, well, sort of rounded, barely rounded, okay? All right, we got two things we can do. All right, we can go look at it. So let's go do that. Remember, that was Zoom 9. Wow, there it is. And see how that's 1, 2, 3, 4, 5, 6, 7. Really great correlation. Super close. Okay. But that's not what it's asking. Okay. So how do I get my 8 and my 18.1 error? Okay. Do second graph and it gives us a table. And I'm going to write this down. Okay. So now this is our Y. Okay. That would be up here. If we did this and we said Y equals, and we put in our 2.4143, and we put in 8 and minus 0.829, that would be very close to 18.486. Okay, this is the estimation. Okay, so this is new information. This Y right here, this is new information. So if we want to calculate that error, and I'm going to use the E for error, okay? That would be my error percentage. It's asking what percent of prediction error, okay? What do we want? I know you don't remember from above, we want to get the new data, okay? And remember, it's absolute value. I could have turned them around because this estimated one from up here, this 18.4486 is larger, but it doesn't matter. We could do 18.486. Now we divide by the estimate, what the equation gives us, okay? All right. So, and you could subtract that easily in your head. Actually, I could turn around, I could do different things, whatever. Okay. I mean, by this point, we know how to add and subtract them when they're bigger or larger, whatever. Okay, so I'm going to turn them around and subtract so I have the absolute value on my numerator. So I'm going to say 18.486 minus 18.1. Yes, you could have done that in your head. Okay, that gives us a little decimal. Now we're going to divide by the 18.486. Okay, and that gives us a pretty good number. We move over the two places in the decimal with some rounding, and we have option C. You guys know if those zeros make your eyeballs cross, especially if you're wearing your glasses, and your eyes are tired, you got your I have thick glasses. So what do we do? Say times 100. Push enter. Look, there it is. Just round that 0 to a 1. Okay? All right. Number 3, an educational statistician is conducting a linear model for predicting using the following data. Okay. Student A has a final exam grade of 80 and receives a course grade of 85. Student B had a final exam grade of 75 and receives a course grade of 82. What is the linear equation that best fits the data in the table? Okay, this is going to be our X. This is going to be our Y. I know it isn't a lot of data, but if you remember, you only need two points to make a line. Okay, so let's enter that. And let's make this. Okay. Right, looks like we have it entered. We have our 80 and our 75 and our 85 and our 82. Okay. So we've got it entered in our L1, L2. So let's back out second mode. Remember that. That's what I'm pushing every time. I know I'm hoping you're watching that as I'm doing it. Okay, so now we enter, we go over to calc, and we need number 4, the linear regression, number 4. And it's all entered. But remember, we have to stop at vars, arrow over, function is highlighted. We're keeping our function. We're going to put it in Y1 and it's highlighted. Enter that, enter again, enter. There's our A and our B. Remember, A and M are the same thing. So we need to put a 0.6. That one works. Wait a minute. This one works. Oh, but it's positive. That one doesn't work. That's not the right number. So this isn't going to work. This isn't going to work. Okay, so now we got that. Now let's look at our B. Our B value is 37, but it's not negative, so D is our option. Okay, now it says on number 4, if student C has a final exam score of 92 and receives a grade, a and scores a grade. Okay, this is final exam. This is receives a course grade. That says scores grade. Course grade. Here. Course grade. It'd help if I could type it in correctly. Okay. Sorry about that. A little typo business. There we go. Makes sense now. Receives a course grade in 93. Okay. Do not. Okay. Before I even push anything, do not go in and add it to the end of your list. That will change everything. And that isn't what they're asking. They're saying, hey, you have a model. Here's your model. What would happen? Okay. So, above on the number 1 and number 2, I wrote everything in. We don't have to do that. We're just going to do this. Set up our error. Okay, we're going to have to go to the calculator to find that. But our new score, we're going to look for 92, but we're going to calculate with 93. Remember, we're using absolute value, okay? All right, but we need to go and see what our model gives us. So we go to y equals, make sure it's in there. It's in there. Second graph. Now, okay, I already have my 92, but yours may be on 1. How do you get it off of that? You go to second window. See where I typed in 92? I'm going to type in a 1 and enter it. Okay? Now, nothing is going to happen, but you need to push second graph again. See how I'm back at the 1? Okay, so I'm going to have to go back, push window, and now I want to be back at my 92 because remember, that's where I'm measuring. Hey, I have a prediction, but I actually have 92. Let's see if how close my prediction was, okay? All right, so you push enter, but nothing happens, okay? It's just gonna like magically be over in the table. There it is. So that is actually 92. I didn't leave myself in here. Let me do this. 92.2 absolute value. Then I divide by 92.2. Okay? All right, so 93 minus 92.2. Oh, see what I'm doing? I didn't back out. That's what happens when you don't back out. Fabulous. Okay, 93 minus 92.1. Push enter. Divide by, again, 92.2. Enter. And if that doesn't make sense to you, you can move over to two spaces. But let's do times 100. Actually, that is our rounded. We just needed to take the 87, and that's our percent. It's less than 1%. So where is point? Okay, that's not a decimal. That's too big. So it's between 0.86 and 0.87. Well, you're supposed to round. So this would be the value. You got to round up. And on a test, I doubt they're going to do this to you. I've never seen it that close. If you see a situation where it's that close, go recalculate your numbers because these tests, even the practice tests, they are analyzed and evaluated by multiple people over a period of time. So I doubt that would happen. Our option is A in this case. Okay, let's look at number 5. Okay, the temperature at which a person perspires is a function of their weight. Sharon weighs 120 pounds, and she perspires at a temperature of 83 degrees. Jim weighs 200 pounds, and he perspires at a temperature of 76 degrees. Find the linear equation for this model. Okay. Man, they're making it nice putting in pounds are going to be our X, and this will be our Y. Okay. Let's put that in. So stat, enter. All right. I'm going to clear it out. Now I don't have to do the clear out. I could just type over it, but it makes it easier to see. Okay. So my X's are 120, and then I need 200. Okay. Arrow over. Then, yep, 83, and then the 76. Okay, now I have to back out or nothing will happen. Then I have to push that, go to calculate. Remember, I'm going to number 4, and I'm in L1, L2, and I stop right here, and I go to my vars. Now I'm needing my Y var, and I've highlighted on my function. I'm going to put this in number 1 and just write over what we had in the Y1 before. Okay, now I have some numbers. I have a negative 0. Ooh, there's my negative 0.0875. Oh, and it should be in front of an X because that's my M. A equals M. Remember? That won't work. And this one does not have a negative, so that one doesn't work. That one doesn't work. This has a negative and the correct B value. That's my option. Okay, moving on. Number 6, based on the data, a health official will use the linear model to predict the temperature at which a person perspires based on weight. If Madison weighs 105 pounds and perspires at a temperature of 88 degrees, what percent of error exists based on the linear model? Okay, this is what we need to go to find the value that goes with our 88. So what are we doing? Once again, we have an error. Okay, so we know that we have 88 are given. That's the actual temperature. Okay, so we already had that typed into our model. Let's go double check it again. Stat. Oh, we don't need to check it in there. You know where we need to go? our Y. Our Y1 is populated correctly. Okay, awesome. Now we can say second graph. There's our table. But again, it's on 1. We need it on 101. I'm not going to sit and arrow all that down. So what do? We push second window. That's where we set our table at 105. Enter. Remember, it will not come up right away, so you have to push second table. And again, to find, what do we need? We have 84.313. And then we're going to divide by 84.313 again. Okay, let's put that in. Oh, remember, you have to do second quit to get out of it, or it won't help you out at all. 88 minus 84.313 degrees. Push enter. Okay. Okay. Awesome. Now we divide. Put that 84. That's our prediction Y. Okay. Enter. Okay. Oh, I think I see the number. Now, if you can't see that from the decimal, just multiply by 100 real quick. And then obviously you can see, oh, yeah, that's it. I was looking up here at A. These are not correct. That's not enough. That's too small. That one's too large. So it is B. Okay. That is our error. All right. Let's go to number 7. Looks like they need us to enter some more stuff. A statistician is conducting an experiment. He rolls a die 1,800 times, and the result of the data of each outcome is as follows. Okay, so we have our table. We have to enter our table, then find the linear equation for the model. Then on number 8, you see the pattern that's going here. Then at number 8, then we need to find, it says use the data in the table and the linear equation. What is the percent if we look at 6? Oh, now this is going to be a little different. Okay, great. Let's get to it. Okay, we're going to do stat, enter. Okay, I'm going to go and clear that out. Uh-oh, uh-oh. Oh, it didn't do it. Okay, good. I thought I arrowed out. Okay, clear, enter. Okay, so we have 1 to 6. Okay, you may not remember how to do this. Let's hope I remember how to do this. Okay, so you go up. So you don't have to enter them all. I mean, you could. So I do believe it is in. No, that's not it. Oh, shoot. I think I'm just wasting time here, but let's give it a try. Second. Yes, second stack, ops. And I go to 5. And then I push X and I enter X and I enter. And I'm going to start at the number 1. I'm going to end at what number? 6, because there's only 6 on a die. And then I'm going to go by steps of 1, and I'm going to paste. I'm going to enter again. Voila. I know, as many buttons as we push, we could have just pushed 1, 2, 3, 4, 5, 6. I know, but just in case on a test or something, you have a lot of numbers, just in case. Okay, we are going to have to enter these 120, 140, 250, 450, 300, and 540. Enter. Okay, make sure they're even. That's like a clue if you made a mistake. Okay, then we have 120, 140. Double check just in case. Great. Now we back out, remember? Back out. Stat. Go over to my calculation. Push my number 4. And I've already populated 1 and 2. Okay, stop at my vars and arrow over, push 1. And we're going to go ahead and put it on top of the Y1 again. Okay, so go ahead and just enter, enter, enter again. There are my values. So remember A is M. So let's look for a positive 79 with the decimal in front of the X. That This is not right. 20, I don't want 22 in front of the X. This X rounds and looks pretty good. That one looks good. This one's negative. My A's not negative. Well, this one's positive. Uh-oh, do we have two that are the same? Oh no, looks like a typo. Yeah. Uh-oh. Well, you know what? Let's circle them both. I think what was going on was this one was supposed to be negative. Hey, I'm not perfect. Let's call it that. Okay. This is our calculator is telling us the B is the option, so we're going for that. That would, like I said, these mistakes won't happen on a test. Now, could be a test for your professor or a practice test given in class by a professor. That could happen. Okay. But this is just you and I studying and reviewing, so we're good. All right. So let's look at number 8. Okay. This is a little different. Given the data, okay, we have the table and the linear regression. What percent error for 6? What they're saying is you need to use this in your error, okay? So we're going to put E equals, and we want to go with, that's our actual was 540, and then we're going to subtract. Now, I don't know what that value is going to be, so I may have to use my absolute. I don't know how big this is. So what do I do? Well, first off, I need to go to, I should be okay. Let's see where my table was. No, I'm not. I'm going to have to change my window to the 6. Enter. Okay, yeah, that's where I'm supposed to be. And then I'm subtracting out 498 minus 57 over 498.57. All right, let's get that done. All right, back out. 540 minus 498.57. Enter. Great. 498.57. Enter again. Oh, did you see what I did wrong? I did not push division. Not a big deal. Go up. You saw how I arrowed up. You see that? Push enter to capture it. Do divide again. Then I go back up and I push enter to capture. Then I do it. Notice how I didn't have to push buttons again. Now, do I have something close? Yes. I'm going to multiply times 100 just so I can see it clear. I need 8.3. And there it is. Perfect. Okay, that is the last question in this video. I hope that gave you a little more review on linear regression and looking at an error. Now, there are other types of errors. I highly unlikely you're going to see that on a test, maybe a practice test, but I'll try to go look out for those and find those for you and come back. If I find something different, I'm going to come back and do another special video and call it a supplemental for you. Okay, thank you so much for watching. If you like this video, give us a thumbs up. And if you haven't subscribed, please, please, I hope that you do. And you know what? The best on all your tests. I hope everyone does fabulous. Thank you again.